Okay, let's start talking about these oblique triangles. Whole new system. The right triangle trigonometry that we were using does not apply to these. An oblique triangle is when you have an angle greater than 90 degrees. So I'll draw my oblique triangle here that we'll just use as our example like last time. Yeah, let's go like this. Now we're still talking about angles and sides the same way. I'm going to call this angle C. I'm going to call the side opposite or across from it side C. I'm going to just kind of pick a random side here. I don't think it matters a whole lot. I'm going to call this angle A. So the side across from angle A will be side A. And that leaves us with angle B over here. Then this would be side B, the side opposite of the angle. Pretty good so far with that? Okay, so there's two formulas that we need to know with this. We're going to do the law of sines and the law of cosines.
That's what I was trying to remember what it was, and it's this crap.
Here we go.
God, I hate this.
It's really not too bad. Law of sines. That says side A over the sine of angle A is equal to side B over the sine of angle B is equal to side C over the sine of angle C. Okay? It's really a lot easier than it looks. Everything's equal to each other, meaning you can pick and choose what you're using here. You're only basically going to use 2/3 of this formula, depending on what information you have. If you have side A and angle A, and you have side C and angle C, you're going to remove this, and you're just going to use these two portions, depending on what you have. And it's just cross multiplication. So in the case of here, if you have two sides in an angle, you're going to cross multiply to solve for the other portion. Not too hard, not too crazy.
Ooh.
The law of cosines. A little bit longer, not too bad. This, you're going to deal with all of the sides in one angle. You'll typically see it written like so. C squared equals A squared plus B squared minus 2 times the side angle A times the side of angle B times the cosine of angle C.
This was the one I always forgot. There's a lot of signs I forgot. This one.
So C squared equals A squared plus B squared in the beginning.
C squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C. And I'd work this up into two parts here. I would do this part, and then do the math to it. So when we look at number 13, We have 3 sides and no angles.
Mm-hmm.
I look at that and say, oh, nards. What are we going to use? Can we use anything in the law of sines? No. This is the only formula we have that has all 3 sides and solve for 1 angle. So we have to do some manipulation of this equation, which I'm not going to go through all the steps to do that. I'm going to just tell you what we got here. So to isolate C on one side of the equation, I'm going to just start from left to right. So the cosine of angle C is equal to C squared minus A squared minus B squared divided by -2 times A times B. Okay? Without going through all the math steps to isolate C, the cosine of angle C to one side, here's what you end up with, what you should have. So now if we look at our triangle here, we'll say side A is 30, side B is 45, and side C is 65. When the triangle is actually drawn like to scale and correctly, the largest angle side across from it's going to be the longest side. So now to work this guy out here, the cosine of angle C is equal to 65 squared minus 30 squared minus 45 squared divided by -2 times 30 times 45. This is probably the most difficult that it's really going to get right here. So take 65 squared, 30 squared, oh, 30 squared minus 45 squared minus, we get yeah. I come up with -0.48148. Take the inverse cosine, arc cosine. Angle C will equal gives me in decimal degrees, convert that to degrees, minutes, seconds. I come up with 118 degrees. 46 minutes, 56 seconds. Everybody come across that? Ready an extra calculator if you want to try it? I'm not going all math teacher, like doing every step by step, but I just kind of want to work this through this much. Make sure everybody follows along with me and comes up with the same answer.
It's giving me error.
Getting an error.
I think I'm not calculating correctly, obviously. So, trying to figure out.
This one does take a little bit of time to work through. Almost as time consuming, but not quite as calculating contours.
No weird.
Way more fun than calculating contours though, right?
I think so. There's more of a gratifying payout when I finish a line. Like when I finished a triangle on that map, on that topo, I was like, I got so many more triangles.
Yeah.
There was no point of even counting until you were done.
Aside from just kind of reinforcing and getting this math into your head and trying to kind of help get you a little bit ready for what's to come in the future of like the FS exam, you have data collectors and fancy calculators that might be programmed. This is what it's doing behind the scenes on you.
Where's the seconds?
You're just gonna do alpha, then it's a plus.
They couldn't have put it with everything else.
Yeah.
Now, one other thing that does hold true with these, once we find a second angle, we know what the sum of the interior of the triangle should be, right? The old n minus 2 times 180, just to help enforce and prove that. The sum of the interior of the triangles, excuse me, should equal 180 degrees. How's everybody, is everybody kind of working along or still kind of?
You are saying that cos A equal C square minus A square minus B square over negative 2AB, right?
Correct.
But when we say negative 2AB, therefore we'll be dividing it over a negative value, which will give us automatically an error. If negative is the lower value.
1300 divided by negative 2700 gives you an error.
1300 divided by minus 2700. Yeah,
Are you
syntax error.
typing in minus or are you typing in negative sign? Those are two different things.
Ah, really?
Yeah.
Because if you type in minus, it's gonna think you're trying to make a formula that doesn't work.
So you need to make it a negative number, not try to subtract anything.
You gotta find the
No,
time.
Which is probably might be what you're.
It should be next to your zero or your period, or your like decimal period, or
Ah,
your decimal.
oh, okay. Okay. Okay.
I don't know for certain, I've never looked, but I'd be willing to bet you $1 there's gotta be some YouTube videos on how to use this
Yeah,
calculator.
I must find something.
I do
because-
not have them. I do not know.
Because this is ridiculous. I'm being humiliated.
It's all good. So we found angle C. 118 degrees. minutes, 56 seconds. Okay, we're chugging along now. Okay, moving on here. So we have our first angle. Let's get rid of the stuff. Too late, got rid of it. Gone, lost forever. Now we need to find another angle. You know what? I'm gonna just work from left to right. I'm gonna start with angle A and then we'll go angle B. So now we're gonna jump over to the law of sines. I wanna find, I have side A, I wanna find angle A. I have side C and angle C. So this is gonna look like 30 divided by the sine of angle A is equal to the side C, 65, divided by the sine of 118 degrees, 46 minutes, 56 seconds. Now we're just going to cross multiply. 30 times the sine of your angle divided by 65 is going to give us the sine of angle A. So the real big thing too you want to remember when you're doing these calculations is when you're using the sine, take the sine, and when necessary, take the inverse sine.
So in the previous calculation, the cos A equal, it showed me 0.9999.
Hold on, let me finish this thought real quick before I get your figure there. So for the sine, I come up with 0.01348. Take the inverse sine, the arc sine, whatever you want to call it. I'll do this one right there. Punch in something else. Yeah. Yeah. So you're still back on the other one still?
So the angle C shows up for you is 18.
118 degrees.
For me, it shows, okay, so the cosine is 0. Minus, it's the cos of the minus 0.5.
So now you want to take the inverse cosine.
So inverse
You're
cosine
just trying to take the cosine of that again. There you go.
okay, of this number, right? of 0.48, but this is the equal the value of 1300 divided by minus 2 times 30 times
Okay.
45 equal this.
Okay.
So when I take the cosine, inverse cosine of that, okay, and close it, and then press enter, and that's the value.
In decimal degrees, so that answer is in decimal degrees, so you
Okay.
need to convert that to degrees, minutes, seconds, yes, sir.
How, I don't know how I got wrong, so it took 3 times the angle I did in decimals. Times the decimal angle, and I got that.
Okay, so here, that 118, that's the actual angle itself, you need to take the sine of that angle.
Oh, and then times it? Oh,
Yes.
okay, that's where I'm wrong.
Yes, that's why, one of the things I just cannot stress enough is when you're doing these calculations, pay attention to what you have written down and that you take the sine of the angle when you're working through this cross multiplication.
In the HP calculator, to convert the decimal to a degree, do you know what to use?
On the HP?
Hmm?
Oh, yeah, on the HP I did. And that, no. With the Texas Instrument, I'm not sure how you do the conversion there.
Because it has convert here, when I click on convert, I'm trying to
Okay.
see which conversion,
Scroll down.
English metric, temperature, speed, pressure, power, these are the options. I don't see angle.
Oh, man, that might be a little bit of a problem there if you don't see that.
But there should be, I wonder if there's something else other than convert, like phase, OP, constants. I wanna know what are these num-solve.
Can you back out of that without doing it? Okay, so now, what about your mode? Mode button, if you hit your mode button,
Oh, good. Degree, okay.
oh, no, I guess not, that's wanna say what the settings actually are, okay. Jake Collin,
What is he trying to? He's
convert from decimal degrees to degrees, minutes, seconds?
decimal degrees to degrees, minutes, seconds.
Yes.
Do you have also Texas?
Yeah, I do. Do you have apps on there? Or I guess it would be angle is what you
Yeah, but this is the decimal value. I wanna change it to degrees seconds, so I was seeing, is it like time
For
times
us, it's under angle, but
angle?
445.
you could try math. Math is usually a really good one that has like a lot of stuff.
I would be certain that it's in there.
Yep. And then, oh, here you go. So this is, yeah.
That's
control now.
angle A, right?
Yeah, if you type in
Yeah.
Yes.
6.
Angle.
So if you do math, scroll over to this and 6, it'll do that, and then you just press enter. But do one more.
Alright.
For the math. Like, you actually press, oh, here, I know why. Quit out, yeah. It's because you didn't, you have something in the answer line, you needed it in the, oops. So do like, oh, that's not, here, if you ever wanna like, reuse the answer you have, do second answer, then this is that.
No.
So then
Well-
now, once you have it at the start.
So
then
Colin, you
go-
have, angle A and angle C solved for?
Mhm.
How you solving for angle B?
I'm just gonna add them.
And then if you have it like this.
subtract it
and
from
you-
180.
And like you type in
Excellent.
like let's
Yes,
say.
that is a very
you took
acceptable
this
way
one
to
off
do
the
that,
paper.
add these
If
two
you
angles
type this
together,
into your
subtract them
calculator
from
and
180.
add the degree sign, add the second sign, and then just press enter. Then enter. Yeah, then it'll take it back to decimals for you. So, but yeah, it's under math, over that tab, and then in that tab, it has your degree sign, it's got your second, and then your, oh, actually, you might wanna look for your, sorry, you have in math, you have degrees and minutes, but you don't have seconds, I don't think. You gotta go DMS.
No.
Oh, no, you do, okay. Cause for us, like, the seconds is on the plus, but you have it in the same, so everything you need to do DMS and go back and forth is in that folder.
Alright, thank you so much. That's very helpful.
Okay. So once
Catching
you,
a thread.
once you get your first angle, you jump over to the law of sines, calculate your second angle, Then to calculate your third angle, you're just looking at, you add these two together and subtract that sum from 180 degrees. Does that match what you guys have?
And in surveying exams, official surveying for licensing, we have to do all these manually, right? Like, or using calculators.
Yes, when you sit for those exams, you're going to have to use that calculator.
Only, we don't have like a computer or like.
Well, the test is on a computer, yeah. You don't have access to any kind of programs or software.
So we're gonna have calculations like these that we have to.
Well, there may be. Now, what they will give you would be a sheet that has equations on it.
Okay, so like. This-
However, a lot of people, like I know with the HP specifically, they would have something kind of like that.
Mhm.
Actually, it'd probably be written out a little bit more looking like what's in the textbook.
Okay.
Some people, I know like the HP, you can program all of this stuff, so like, oh, I got two sides and an angle, calculate the whole triangle, and it runs through it.
There's a handbook for the tests that you're allowed to use, and it has like tons of formulas and like everything.
Okay.
They provide that to you, you're not gonna walk in with that. The only thing you're gonna walk into that exam with is that calculator and that's it. No phone, no smartwatch, no
pencil?
keys. They actually give you like a small dry erase board.
Okay, but they'll give you something to write, like to do written work. Okay.
Yeah.
So that if you're not allowed to write for that test, I don't think I
Good luck.
wouldn't even take it. Wouldn't even take it.
Good luck.
Yeah, I would not be sitting
Yeah,
here
you
today.
gotta sound some of that stuff out on a piece of paper.
Sure, definitely.
Mm-hmm.
But also to kind of prep and think, get this stuff down, at least be familiar with it.
Mm-hmm. Yeah.
And also to know when you're just throwing stuff into your data collector, what it's actually doing behind the scenes. It's spitting out these answers like instantly. This is all the calculations that it's doing.
Yeah.
I'm not familiar with the TIs or the Casios if you can program those.
You can on these, at least the 84 you can. I don't know about his.
Yeah, I'm not sure about the smaller versions of the TIs that are legal for the exam.
Is that legal for the exam?
I can't use this one.
No, not the
Because
48.
you can like program and like put whatever you want into this, and then I don't know. I feel like the graphing probably too is why they don't want people to have their own like graph
Yeah.
as a calculator. That you could get away with a lot of easy calculations if you could make your own triangles. If you knew how to do it. Because you can I could put into this. You probably could too, honestly, if you have program. Like you could put in the law of cosines into a program, and then if you type in program and you pick the one that is your law of cosines, it'll be like, what values do you want? You give it the values that it needs, and it'll just solve it for you. And you can do that with like anything you want. I remember, back in the day, I put the unit circle in my calculator because I didn't want to memorize that. And now every time I use the unit circle, they give it to me, so I'm glad I didn't memorize it.
Also, take a quick look at this. This is kind of a real quick visual check. Pay attention to. Look at the values of your angles and the values of the sides. The largest angle is going to be opposite of the largest side. The second largest angle is going to have the second largest side. The smallest angle is going to have the smallest opposite side. So once you run through your calculations, just, that's a quick, easy, hey, does this make sense? Does this look right? Am I in the ballpark at least? That's something I like to look at and just kind of just a quick visual check,
In this book, you recommend having a hard copy of it, or like a soft copy is fine? And I mean, from a practical point of view, like is this a kind of book that
this book here?
Yeah, it's kind of book that we're really down in the road of our career. It's good to be handy with it.
I think it's good. Like I've always kind of said to my kids when they were growing up, and I've said this before in our classes too, you don't have to memorize every single fact and every single equation, but you kind of need to know where to find the stuff that you need to know. So this could be a good reference for that, like, oh, what was that equation or something? Oh, I remember it was in this book. You can grab this out. And it is a good book.
Because I usually like to get ebooks, so because I can. Throughout my life, I traveled a lot, so I learned that getting ebooks.
If you like ebooks,
So those are what, but in case some books are like really better to have them hard books, so like kind of, then.
Personal preference, if you prefer an ebook over an actual book, hardbound. I don't know if they even make this like a paperback. Probably not. Probably only hardbound.
Okay.
But if you prefer an ebook over a regular old-fashioned book, get the ebook. Should we go through another one?
Okay.
Have you guys gone through all of them already? Way ahead of me?
Nah, walking with you.
What are we looking at so far? Do we want to jump down to 14 or do we want to jump down to another one? So 16, 17, 14?
Let me see 16 maybe.
We'll do 16?
Mm-hmm.
Okay. Yeah, 16 would be fun. Okay, so I'm gonna keep this up here. What do we know? I have angle B, 78 degrees, 59 minutes. I'm just, because I'm weird like that, I won't put seconds. We have side A, I'm still in 16, side A, 432.12. And we have side B,
So
657.78.
So we can get angle A because B over sine B equal A over sine A, and we have already A, B, and sine B.
Correct. So
So we
yeah,
can
we can
sine
jump
A
straight into the law of sines. We don't need to worry about the law of cosines here.
So sine A equals sine B times A over B.
Yes, so we will use B over sine of angle B. We know that equal to side A over the sine of angle A. Right? So we know these two components. We know this third component. So just write that out. So side B would be 657.78 divided by the sine of angle B, 78 degrees, 59 minutes, 0 seconds, equal to, and we know the side of A, 432.12 over the sine of angle A. Cross multiplication. I always put my pens, pencils, markers, calculators down, but I never put them down where I need them. Gosh darn it. So. what I get as the sine of angle A. Once I hit this, I need to take the inverse sine, or the arc sine, whatever you like to call it. Okay, so something I tend to do also, I kind of forget about, like, I just take for granted some of the stuff that I know, and this is some of the first time some of you guys have seen this. I keep mentioning, make sure you're paying attention. Are you using the sine or doing the inverse sine? Before you do the sine of this angle, I have it written down in degrees, minutes, seconds. Convert this to decimal degrees. Then take the sine. Likewise, when you get to this point and you take the inverse sine, you're going to get this answer in decimal degrees, converted to degrees, minutes, seconds. Those are a couple things where people might get tripped up, like, hey, wait a minute, you know, I got some way different numbers than you do. Take this angle, convert it to decimal degrees, take the sine, multiply by, cross multiply, and divide. You're going to get this little decimal here, which is the sine of the angle. You need to take the inverse sine, arc sine, and that's going to give you an answer in decimal degrees. Convert it to degrees, minutes, seconds. So now we have angle A. Does everybody, anybody have this same?
So how I can select that to be the answer I can move it.
So yeah, you gotta be like a fresh line.
Yes.
Honestly,
Sorry.
wanna-
Going back.
what do you wanna
So you
do?
take this after you take the
So
sine,
this number.
you times it by 432.12,
Yeah.
Yep.
and then you
If you're
divide
using circle equations, you can just go
that-
ahead
that
and
number
just start
by
typing.
whatever you get.
But if you want to
Yep.
use it like, let's say you have to do division, and like the order matters, then you could do like, let's say you want to divide by 8. Then if you wanted to do it, make it like somewhere else in the equation, then you could do second answer. But it's second answer for anywhere else, but if you just wanted to start, you could just start typing, and it'll remember.
So making sure you pay attention to using your sine or inverse sine, converting degrees, minutes, seconds to decimal degrees and back. Those are little things that will get you tripped up. Just be aware. It's not a race, so you don't have to try to speed run this stuff. Everybody feeling okay? Did I do this correctly? Uh-oh. There's something a little different. Did I do something wrong? Let's see the gears turning.
I just got it. I got that same answer. I
Okay.
was dividing this 657 by the number, but I was supposed to do the number and then 657. And then I got your answer. Does that make
Okay.
sense?
That's 16 angle A, 400911.
That's what I got. What'd you got?
400911.
Alright. Angle C will be easy from here, right? Now we have two angles, we can easily calculate that third. Well, I feel like sometimes I look down at my calculator, I see the number and I look back up and it's like, what did I just look at? Kinda like, when you look at the time on your watch and then as soon as you look away, somebody's like, hey, what time is it? And you gotta look again even though you just looked.
That's how I forget, because I'm not writing anything down, I'm trying to do all these in my head, and I'm just like losing numbers, having to go back and find them. I'm getting results.
So the last thing we need to find would be side C. We know angle A side A, we know angle B side B. What do you guys want to use?
Law of science.
Well, we're going to use the law of sines. You want to use A, or you want to use B?
I picked that.
You picked A? Alright. So we know the side A is 432.12 divided by the sine of 40 degrees, 9 minutes, 11 seconds is equal to side C divided by the sine of 60 degrees, 51 minutes, 49 seconds. Right? And we're just going to do our cross multiplication again to solve for C. So, convert degrees, minutes, seconds to decimal degrees. Then take the sine. For this guy here, multiply it by this side. And then take this angle, convert it to decimal degrees, take the sine. And you should end up with what side C should be. What you got? What you got? What you got? What you got?
Oh,
Any-
I got
Anybody?
585.33.
Is that right?
I'd like to think so.
Anybody else confirm or deny? No confirmation or denial?
Yeah.
then what I'm also gonna do there is take a quick look, thinking the largest angle is gonna have the longest length side opposite of it. B looks like that is my largest angle. That looks like the longest side. This is the second, the middle. Yeah, that looks good. This is the smallest angle, smallest side. I feel pretty good. That's a really quick, easy visual check. So after working a couple of oblique triangles there, does the right triangle stuff seem a little easier now?
Yeah. Honestly, it seems easier than I remember it. I don't know. So, which is good.
So here's the thing, let's put this survey, think of this survey-wise. You have an instrument set up here. You take your back sight here. This point's gonna be your foresight. I shoot my back sight, I have this distance. I turn my angle, C, and I shoot my foresight. With that information alone, I could calculate what is that line, what's the distance of that line without actually measuring it, which we would call an indirect measurement.
Because that's the length you're trying to find is that side seat. You're trying to go find from backside to foresight.
Maybe there's a case, you know, that this never happens. You're on a job site, you want to set up on this point, backside this point, but lo and behold, there's a bunch of equipment parked in the way. You can't see between the two. You could set up, shoot this angle, shoot this distance, turn the angle, shoot the distance, and do this math, and you could calculate what this location is. We like to call those resections. And depending on who you work for, various surveyors and things have different schools of thought, whether they're good, bad. Do it all the time, use it as last resort. So yeah, that's just try to kind of implement a little bit of surveying possibilities here. Or if you're running a traverse and these were two side shots off of your traverse, you can calculate the length of that line if this was maybe two property corners or something. Pretty neat, huh?
Now you couldn't do that. Like if you had like a big traverse and you had to do multiple points, you couldn't. If you're not making triangles, you can't use this.
Correct, but everything we're doing is going to be a triangle.
Okay.
It's just a matter of
You can always find a
visualizing.
triangle. Okay.
It's just a matter of visualizing that triangle.
Gotcha.
Okay, I'm going to leave you here with this. So we worked through a couple. I have a lab module or a lab assignment in the this week's module. What I'd like for you to do is go ahead and complete the right triangle and the oblique triangle. Excuse me. Complete these charts and submit those, along with, if you got an extra worksheet where you're drawing everything out, you got extra work, take a picture of all of this and submit it there in Brightspace.
This one.
Mm-hmm.
You don't need the one from earlier. The review sheet.
So I didn't realize, or I forgot, not gonna lie, the first sheet we worked on where we were doing the angle measurements, that was actually like a homework, and you can submit that in Brightspace on your homework. I forgot about that, didn't realize that for the first class. Yeah, that is actual like a homework assignment to be signed on Brightspace, or submitted. And also please make sure you, well, when you submit in Brightspace, I guess I'll know whose it is, but you know, sign your name to it. I don't think I assigned a due date, but we'll say that this is due by the beginning of lab next week. Does that sound fair?
Very fair.
But by all means, if you want to submit it earlier than that, knock yourself out. That's a go-getter attitude we like to hear.
Oh yeah.
Oh, yeah. All right.
Oh yeah.